My name is Miguel Duarte. I'm a software engineer working for Red Hat in the OpenShift virtualization networking team. And unfortunately for, well, all of us, but especially you, my colleague Doug could not be here to give the talk with me. So it's going to be pretty much just me. This talk is about two new verbs that were added to the CNI spec in version 1.1, and with these new verbs, you can do more things, and I'm pretty much going to explain what they are, why these are useful, and, well, what new things you can expect from the CNI specification. So first, I'm going to walk you through like what I'm going to be saying, and I'm going to start with a very brief introduction into the CNI well, architecture and specification. I'm going to try to define the problem, and then I'll introduce these new verbs. There's going to be like a live demo. I hope the demo gods stick on my side this time, and I'm going to conclude everything. So first, some CNI basics. How many of you have worked with CNI? Okay, written a plugin or something like that? Okay, not many, but okay, so I think you understand most of this, but still, let's be here. Let's spend a little bit of time on this one. So first, CNI pretty much operates as an executable that is installed in each node in the Kubernetes cluster, and it's invoked by the OCI runtime. That's right here. So what CNI actually does is it creates the pod sandbox, and that's essentially like the network namespace where you'll have like the interfaces for your pod. So whenever a pod is created, this, like the runtime, will pretty much invoke CNI and say like configure networking for this pod. And it will pretty much just create the interfaces, configure the interfaces depending on its configuration. An interesting thing, as I said before, it's just like a binary that's located in each of the nodes in a well-known location. This can be overridden again in the configuration, but usually you will find the plugins in this folder right here, and the configuration for the Kubernetes default network is also commonly found here. You can override it in the configuration, but this is where you'll usually see it. Now, how does it look like? This is for an add operation. So whenever a pod gets created, it will, the runtime, that's right here, will invoke the CNI plugin. And for the add command, it is forced to pass this information using environment variables. And that's like the command, which in this case is add, the container for which it is creating the runtime, the name of the interface, and the path to the network namespace. It will also give a bunch of configuration in a single string via standard in. And it's a JSON formatted string, which will have things like the protocol version, the name of the network for which it's creating, and very important, the type of the plugin. That's the way it will find the executable in the node that it needs to invoke. And it will spit out like an error code, or like 0 if it's okay, or an error code, and it will also issue on standard out like the result. On the result, usually the interesting things you'll see there is like the IP address, for instance, MAC address, that kind of information. This is a list of the operations that you can have in CNI up to now. So I'll be speaking about the new ones. These are, let's say, the old ones. So add is invoked by the runtime whenever a new pod gets created. Delete is invoked by the runtime whenever a pod gets removed. Check is something that is invoked by runtime to say like, dear pod, is this pod still okay? And it will say yes or no. And version, well, it's pretty much like self-explanatory. Now, what's the actual problem? So there's a couple of questions that sometimes are very useful to make, and this is the first one. Like, how do you know if your CNI plugin is actually ready? How do you know if the cluster is ready for the network to be created? Right now, you have no answer to it. You pretty much have to assume that if I have a configuration file, this is ready. And this is pretty much all the information you have. And the fact having a configuration file is not a good indicator of anything. So yeah, if you had like a semantic way of figuring out if the dependencies of your plugin are ready, like for instance, let's say in this case, is the database ready? Is the storage ready? If all these things are ready, the plugin will say, yes, I'm good to go. And essentially, it provides like a semantical way for you to know if your cluster is ready to accept things. Another very interesting thing is for those of you that actually work with CNI to the point of writing plugins, is like CNI delete is not guaranteed at all. Meaning, let's say like the Kubernetes node like just goes down, for instance. Well, there's no one that will issue the delete call. That's kind of obvious, but at the same time, it's a little bit surprising because obviously, if the call that kind of tears down the things that got created when the pod was added, if the delete is not issued, like who's going to clean that up? Up to now, the answer is, well, you have to do that. Like the plugin itself cannot be that simple and dumb. It needs to be a lot more complex to be able to clean that off. And that's not good to push that kind of decision to the plugin. Another thing that can happen is like when the user force deletes the pod, also CNI delete does not get called. So again, you have leaking resources. Yes? I mean, so the question is, what's the use case for storing information? And I mean, let's say for instance, IPAM, you need to know the allocations that you have. For instance, well, you want it to persist somehow. Like if you can, for instance, I mean, it's early in the presentation for this, but so for instance, let's say, usually you get to figure that out by looking at the runtime. Like you look at all the pods in the system, you look at all their IPs, and you figure that out. But let's say, for instance, you have VMs and they're stopped, but they have allocations in it, and you want those allocations to persist. So there are no running pods, and you do not know their IPs. So you need to have a different way. So that information has to be persisted somewhere in whatever way. I mean, it's an example. I'm not saying that, it's an example only. I hope that makes sense. Thanks for your question. So now, the new verbs. And I hope by now we understand why they are useful. I'm now going to introduce them. The first one is status. The goal is quite clear. You want to know if the network is ready to accept traffic. And how it does it, like according to CNI spec 1.1, it pretty much returns an error code or 0 if it's ready. And the error codes can be like 50, which means that the plugin is not available. That means that I will not be able to add things to this network. And there's a different error code that says I am not ready to accept things in this network. And the network, you cannot trust the state of the network right now. If you have running things, it may not be working as you would expect. So that your runtime can kind of adjust to this and react in whatever way it sees fit. The other command is garbage collection. So if we take a few steps back and remember CNI delete is not guaranteed, and we think things might leak in the cluster, things like IP addresses, and that's like let's say that for instance you have like a very short subnet with like, I don't know, 16 IP addresses, and you're leaking things behind, you will not be able to schedule more stuff, and that's like a very common problem actually. So this new verb allows actually the runtime to say to the CNI plugin, these are the things I want to keep, you can get rid of everything else. And this is like the JSON formatted string that you need to send via standard in to the plugin. It's pretty much like the list of attachments that you want to keep. So for every container, you say the name of the interface that you want to preserve. And the plugin will pretty much get rid of everything else. So this is like a visual way of seeing it. Let's say we are persisting the IPs in a database outside of the system for whatever reason. We have our CNI plugin that is like creating things, and we have the runtime that is pretty much like managing the life cycle of a set of pods. Now, for whatever reason, there's a weird disaster, and this pod goes down. And CNI delete is not invoked for whatever reason, which puts us in this situation. Like the IP address allocation for that pod leaked behind, and we have something stale in our database. Up to now, we had no way of identifying the situation and no way of actually going and reaping this stale IP address from the cluster. What would happen right here would be the runtime would invoke the CNI plugin, which would tell it, I want to keep Ethernet 0 for the pod number 1 container, and I want to keep Ethernet 0 for the pod number 2 container, and it would pretty much know that it would be able to delete the pod number 3 IP allocation. And yeah, let's go to the live demo. I hope this works. You can find and follow it in this link. You just have to clone the repo. I hope the README is understandable enough, and but you should be able to follow it if you just go to this link. So yeah, the first thing we're going to be seeing is the status command. So what I'm going to do, like what the demo is about, is pretty much what we're seeing in here. So I have like a PostgreSQL database. I have a CNI plugin, and the plugin is pretty much like totally useless. It kind of behaves like static CNI. So you just say, I want this IP, and it will pretty much give that IP back to you, and it will persist that IP in the database. That's the only thing this CNI is doing. But I just want to illustrate the concept. So what we're going to be doing here is I'm going to invoke the status command. The database is going to be down, and the status is going to say, hey, I'm not ready. Then I'm going to start the database, and it will be OK. So the first thing we're going to be doing is invoke the status thing. This is garbage collection, so the status. And I have to pass it like the name of the network. I am not using Kubernetes here. I'm just invoking the plugin using something called CNI tool, which emulates, in a way, the runtime. So this tool pretty much is operating the same way the runtime would. So in this case, it will just invoke the status command. And as we see, it just tells us that the network with the name IPAM status is not ready because it could not contact its dependencies, right? Now, if we start this database, so we're going to start like using the host network namespace, and it should be ready in a few seconds. So let's try to issue the same command now that we have the dependencies for the plugin already. So the plugin will pretty much just see if it can contact the database, and if it can, it will say that it's ready. And as we see, it pretty much outputs that the network is ready for add requests. So in real life, what would happen here, instead of this CNI tool thingy, what would happen is the runtime would issue these things, and it would, if the dependency were not ready, it would not allow the runtime to actually create the pods, but until all the dependencies are met. So now let's look at the other scenario, like for garbage collection. The first thing I'm going to need is to kind of provision some fake workloads in the system. So I'm going to do exactly the things we've seen here, and I'm going to fake create 3 pods. Like in reality, what I'm just doing is like putting IP addresses on a database. So nothing serious. So let's do it. As I've nothing special here, like it outputs the CNI version and it outputs the IP address that we allocated. So first, let's do it for pod 1, pod number 2, and up to pod number 3. Let's just look at the contents of our database. So at the end of the day, this is just like a MySQL thing. And as we see, we have 3 addresses in our database. Now, what I'm going to do is like simulate that I'm a Kubernetes node, and I'm going to say to the database, I want to keep everything because everything is okay. All the pods that I'm controlling, I still see them, they're still alive, so I'm going to be preserving them. And for that, I'll do something like, okay, so I want to keep the allocations for pod 1, pod 2, and pod 3. Like everything is A-okay. I want to keep everything as it is. And it pretty much just looks at all the attachments that you want to keep. It looks at the state of the database, matches, and does absolutely nothing. So if we do this again, we'll still see that we have the 3 allocations. Now, if we just go here and remove one of the pods, you'll pretty much be saying that I want to keep like the allocations for the pod that I know that are alive. Like this would be useful in a way that like one of the pods got force deleted, for instance, or it crashed for whatever way. And the node, like the runtime in the node would, for instance, periodically be running, and it knows, okay, this pod is no longer here, so it actually doesn't know about the pod. It just looks at the pods it knows about and says to garbage collection, I want to keep pod 1 and pod number 2. And the plugin would look at this and say, but I have an allocation for a different pod, so I'll just get rid of it. So in this case, it deleted one of the allocations, and if we look at our database, we will see that the allocation that we had for the pod that got deleted or crashed or something was deleted from the system. Again, in real life, I probably should go there afterwards in the conclusions. So let's reach that right now. Now, thing is, where do we stand in with all of this? So the thing right now is that this is not currently usable for the simple fact that the runtimes do not implement these calls yet. So the specification has these things. The plugin library allows you to call it, but simply the runtimes do not invoke it. So like the garbage collection call is never invoked from the runtime. And if we take it like a few steps further, it's not even decided when the node is going to be issuing the garbage collection thing. So far, it's pretty sure that when kubelet boots up, it will, like, the runtime will say garbage collect for the things it knows about, but then it's like, okay, it's probably going to be periodic because that totally makes sense, but the events in which they will issue the garbage collection thing are not even decided yet. So yeah, and there is not, for instance, nor on Cryo nor Containerd, you don't have any sort of implementation of this. Like in the next few slides, I will give like a list of PRs with some ongoing work for this, because there is ongoing work, but it's still not ready. And then we kind of need to ask ourselves, like, these things are issued by the runtime, and the runtime only knows about the default cluster network. So in multi-network, this will not be issued at all, because the runtime doesn't even know about the other networks. So if you want to have like things like status or garbage collection on secondary networks, you will need to be invoking this yourself from somewhere else. So you'd be having to manage these things yourself, which is not good. And there's actually, if you take a look at the last thing here, is a little bit complex on how the concept of multi-network will work here at all, because if we remember, you just, on the garbage collection, for instance, you pretty much just say, for this container, I want to keep this interface. And the plugin will be invoked with that. But if you invoke if you have multiple networks on your pod, what will happen is doesn't have enough information to know which of these to keep because like it doesn't know which network the interface belongs to. So the plugin knows what it manages, but it is not going to be able to figure out which of the things to delete. So there is still some work to do here. And as I said, there's a list of PRs here. So on containerd, for instance, that I know of, there is no ongoing work for adding status on Cryo. It's closed. Like we just have to import like to bump the version of a library. So yeah, there's here like a list of PRs that you could follow if you're interested in this, and same thing for garbage collection. But the bad news here is that there isn't yet any, let's say, ongoing work to implement it in the runtime itself. So nor containerd nor Cryo have it. But there's something on Multus, for instance, and on the CNI tool thing itself. And yeah, this is pretty much the end of it. If you have any questions, I would happily take them. So yeah, sure. Mhm. Right. So I got it. I got it. So the question is, so in Kubernetes, it's like a declarative model where everything is pretty much built to you express how you want the system to look like, and the system will try to do it or fail. And CNI really does not work that way. So the question is, if have we considered a way of kind of explicitly forcing CNI to behave in a declarative way? And if you take a look, there's like some open issues on CNI, and that's actually the goal for CNI 2.0. So that's a goal. Now the path to get there is like totally uncertain, but at least that's the intention, like to force the CNI instead. So right now it's like a binary executing on installed on each of the nodes that gets invoked on certain events by the runtime. The main idea would be to force something, to force it to run. It would have to run on every node because it needs to do nodes local operations on behalf of the containers that are created, but part of it would run containerized, it would be invoked, and would have like a reconcile loop. So that's pretty much the answer. Like, it's a desire the community has. It's being tracked, but how to get there, it's very uncertain at the moment. But it's in the roadmap, so to speak. Any? Sure. Okay. So the question is, all serious CNI plugins are already let's say, control loops. And the question is if I know any CNI plugin that does not do that. Well, if you actually take a look at all the CNI plugins that are shipped on CNI, like on github.com, container networking CNI/plugins, none of those do that. I mean, but yeah, you can probably say that those plugins are there just for reference and you should not be using them in production. That's like probably a point you could make. But yes, let's say plugins like Calico, Oven Kubernetes, KubeOven, all of those pretty much implement this themselves. But if you give them like a standard way of doing it, probably it would be helpful. Yeah. Uh, Welcome. Any more questions? Sure. Mhm. Yeah. I mean, I probably explained myself really bad there. But the thing is, so let's say it's at the end of the day, it's just like a binary running on a disk, right? But it would need to know which of the interfaces that are on this pod I created, because at the end you're giving like a list of things you want to keep. So the interfaces that the other plugin created on that pod, it will pretty much stomp on all of them, unless it knows the subset of interfaces to look at. So let's say you have two plugins and they created interfaces on the same pod. The first plugin created like interface 1 and 2. The second plugin created interface 3 and 4. And the garbage collection would say to the plugin number 1, which is the only plugin it knows about, keep interfaces 1 and 2. It would just stomp on interfaces 3 and 4 that were managed by something else. So it needs to know, okay, of all these things that are here, I am only responsible for these two. So this thing would have to be embedded into the plugin. It's doable because you have things like the network name on the configuration, so it can kind of map to that. But let's say that you have one pod, multiple interfaces, and for whatever weird reason, you have actually attached multiple attachments to the same network in the same pod. It doesn't know which is which. Like, that thing is actually tracked on the on an issue that I've linked here. Like this last bullet point here, current garbage collection spec might not work for multi-network at all. That pretty much tracks that that concern. Any further questions? Okay, so I guess I'm off the hook now. Thank you.